Hello everyone. Let's begin with task 9, that is the last task for week 2. Now this is a real world application of how we can use programming tools to find out solutions to real world problems. Okay, so this is a basic circuit in electronics engineering where you want to connect an LED to a high voltage source, and you don't want the LED to burn out. So what you usually do is you add a current limiting resistor in series to it. Now our task is to find the value of the resistor based on the input voltage applied. Okay, so this is what we have to find the value of R given the user enters the input voltage. So user enters V and we have to find out R. Okay, so now in this hint section, if you just go down, you will see that there is a hint given that this is a known fact. The maximum current that an LED can handle is safely an LED can handle up to 20 milliamps. Some LEDs can handle even more current, but let's assume that our LED is able to handle only 20 milliamps current. So we have already established that I, that is the current inside the closed loop, is 20 milliamps, and the voltage dropped by the LED. Now usually as a standard, it may vary from different colors of LED. It may change slightly from 3 to 2.8 or even 1.8. So but in our case, let us assume that the current inside the loop is 20 milliampere and the voltage drop across the LED is 3 volt. Okay, then by simple Ohm's law we can find out what is the resistor required in series so that the LED doesn't burn out. Okay, so we can find out by actually by simple okay, so let us draw this diagram in on a simple piece of paper. Okay, so let's take this. I have drawn the circuit over here. Now I have already said that my value of I is 20 milliamps, and the voltage drop across the LED is 3 volts. Okay, so I have mentioned it over here. So now if I apply the KVL, and if I just mark the polarities, uh, so this will be nothing but this will be minus V, then plus 3 plus IR is equal to 0, right? So this is, I've just applied KVL. Now if I just adjust this and take IR to the other side, so what happens is IR is equal to V minus 3. So R is nothing but V minus 3 divided by I. So this is our final formula to find out the value of resistor, right? So it is V minus 3 divided by I. Okay, so let us begin programming. So let's start by declaring the variables. We need one variable to store the value of the voltage that the user is going to enter, and another variable for storing the calculated resistance, right? So let us begin with declaring the variables. Now these variables are there is a fraction involved, so I would use the values as integers. Okay, so I will use the values as float because they can have decimal places, right? So float, let's say voltage and resistance. Okay, then I would as always I will start with start describing the program. LED resistance finder. Okay, and I will just add few new line escape sequence, and then start by taking the input of voltage from the user. So I will just say scanf, and I would say percentage f because the type is float, and ampersand sign, and voltage ends with a semicolon, and also tell the user as to what he has to enter. So I would just say enter the input voltage. Okay, once that is done, now I can write the formula for resistance. Resistance is equal to V is voltage minus 3. So this is inside brackets, and then divided by value of I, and I here is 20 milliamps. So I would just do 20 and divide by 20 into 10 raised to minus 3, right? So 10 raised to minus 3 is nothing but divide by 1000, and so this division of division, so this will become multiplication, right? So this will actually go on, I can write it as voltage into 1000. Okay, and then divide by 20. Okay, and this is one way of doing it, or you can actually write it as just a point value, so that will also do. Okay, so once that is done, I would love to keep this inside brackets so that I know what is happening first. Okay, so once this is done, I will just print the value of the resistance. So printf calculated resistance is percentage f and resistance. Okay, so I hope this would be enough. Let's say the input voltage is of 10 volts, so the calculated resistance is 350 ohms. Okay, and if I want to restrict the number of decimal places, I can just do this, and let's say I want to this time 12 volts as the input. I will need 450 ohms resistor to block this. Okay, so I hope you have understood how C programming can be used to find solutions to real world problems. Okay, so see you in the next week.